October 7, 2025, the European Space Agency released the first official images of 3I Atlas, the interstellar comet racing past Mars. The world expected breathtaking detail, an iconic snapshot of a visitor from another star system. What arrived instead was a single blurry dot. Silence followed from NASA, China, and the UAE. Social media exploded. Amateur astronomers claimed sharper images than billion-dollar missions. Rumors of impossible chemistry began to circulate. Suddenly, the most anticipated flyby in years became a mystery. The question on everyone's mind: what are the agencies not telling us? At 9:22 UTC, the ESA's first images dropped. Within minutes, space enthusiasts, meme pages, and science channels shared the same underwhelming frame. A faint, blurry dot, barely brighter than background noise. By noon, hashtags like "Near Fuzzy Dot" and "Where are the pics" trended globally. Comparisons flooded in. Backyard telescopes, some costing a fraction of the ESA mission, seemed to capture more detail than the billion-euro spacecraft. Critics suggested a cover-up, pointing to the silence from NASA, China, and the UAE. The pressure for explanations grew with each unanswered question. Quick pulse check, comment dot if you think it's just physics, or plot if you smell a cover-up. The KSSIS camera aboard the ExoMars Trace Gas Orbiter was never designed to chase interstellar visitors. Its mission? Map Martian surface features in sharp color, detect landslides, trace frost, and observe dust. At 30 million kilometers, the camera's limitations became apparent. Each pixel covered roughly 340 kilometers, enough to erase entire Martian volcanoes, let alone a comet nucleus only a few dozen kilometers across. Its resolution, 1136 microradians per pixel, set a hard ceiling. No matter how perfect the focus or long the exposure, anything smaller than a pixel would blur. Nick Thomas, principal investigator, explained that detecting 3I Atlas was already a stretch. The comet's brightness was at least 10,000 times fainter than the surface features KSSIS was built to image. The team stacked exposures, tuned tracking, and squeezed every bit of signal from the noise. The result? A fuzzy dot. Not a cover-up, but the limits of physics. The coma, thousands of kilometers wide, blended into the background. The nucleus was invisible. At these distances, even Mars' best hardware could only confirm presence, not reveal secrets. What the public wanted, a portrait, became a fingerprint. If you want us to publish a no-jargon explainer on pixel scale and microradians, like this video so we know. NASA's high-resolution camera aboard the Mars Reconnaissance Orbiter promised sharper views. Its optics can map rover tracks from orbit. At 30 million kilometers, it could have captured a glimpse of 3I Atlas's core. But HiRISE went dark. A US government shutdown froze uplinks, status logs, and public data releases. Amateur astronomers anxiously monitored the archive. Nothing appeared. Planning files were missing. NASA's silence turned attention toward other Mars missions, China's Tianwen-1 and the UAE's Hope. Both tracked the comet but released no data, statements, or denials. The absence of information only fueled speculation. In the days after ESA's blurry dot went viral, the internet erupted. Amateur astronomers from Italy to Japan shared deep stack images and AI upscaled versions, claiming hidden structure, jets, cores, or tails. Professional astronomers countered with simulations showing stacking and AI upscaling could amplify noise, creating false structures. Terms like sigma clipping, deconvolution, and pareidolia trended as users dissected raw data. Even the best amateur images relied on aggressive enhancements. Every new processed frame blurred the line between reality and illusion. The call for rigorous, transparent analysis grew louder. Software tricks alone could not replace hard data. On October 7th, Mallory Lefferlin, Perseverance's shift lead, authorized a special NavCam sequence. 10 minutes of continuous sky exposures to capture 3I Atlas. The result? A faint streak just over a pixel wide, diagonal across the image. At first glance, it resembled a cosmic ray or glitch, but the timing matched the comet's predicted pass. Traveling at 90 kilometers per second, 3I Atlas would cover roughly 54,000 kilometers in 10 minutes, the same length as the NavCam streak. A distant, fast-moving object, too faint for a single frame, could appear exactly as observed. Without original FITS headers, exposure times remained uncertain. Was it the comet or a nearer object? This streak became the first measurable clue in a sea of speculation, a 54,000-kilometer question mark. The passage of 3I Atlas within a few degrees of that point sparked online calculations. To match a WOW signal-like strength from 600 AU, a transmitter would require half to 2 gigawatts, like a major power plant beaming energy across space. Yet no hydrogen line data, coordinated listening campaigns, or raw spectra were released. The silence extended beyond optical to radio frequencies, deepening the mystery. On October 29th, 3I Atlas slipped behind the sun from Earth's perspective, vanishing in solar glare. For nearly 40 hours, no ground-based telescope could track it. Models and speculation flourished. Some astronomers predicted natural outbursts or breakup under solar stress. Others suggested the possibility of engineered maneuvering. The Galileo project, dedicated to searching for non-natural phenomena, began round-the-clock monitoring. Until the comet reappeared, only theory guided observers. When it emerged, brightness, trajectory, and fragments would test the boundaries of nature and surveillance. Early November became a critical checkpoint. Astronomers analyzed brightness curves for sudden surges or drops, signaling fragmentation. Orbital models were tested for tiny deflections caused by jets or outgassing. Every measurement represented a pass or fail. Did the comet behave naturally, or was something else at play? The JUICE spacecraft's instruments promised fresh observation, but raw data wouldn't reach Earth until 2026. Comets C2025A6 Lemon and C2025R2 SBU added complexity with unexpected brightening and close approaches. The cosmos reminded humanity, vigilance is never complete. On October 7th and 8th, 2025, 3I Atlas became both a scientific and social phenomenon. ESA's blurry pixel ignited global debate. Hardware limits, government shutdowns, and silence from NASA, China, and the UAE left major data gaps. Amateur observations fueled speculation, while Perseverance's NavCam streak offered the first measurable clue. As the comet vanished behind the sun, anticipation for November's observations grew. Tracking fast, unpredictable visitors remains a challenge. Despite worldwide attention, the true nature of 3I Atlas remains unresolved, highlighting both the limits of current technology and the critical need for open, transparent planetary science data. If you want unfiltered updates, subscribe now and comment with the single question you want space agencies to answer first.